Welcome. This video covers a review for test 2, and I'll be working problems out that are going to be similar to what you'll see on your test. All right, so for number 1, I'm going to solve the equation, and I can tell by this equation that is a quadratic that I am going to be able to factor it. So I'm going to solve this by factoring. So I'm looking for two numbers that add to get the middle term and that multiply to get the last term. And sometimes I like to draw a little X and I put the add number at the bottom and then the multiply number at the top. And so I'm just looking for two numbers that meet those qualifications. And if I'm not sure right away, I can always start with the -7 and I can think what times what equals -7. And I really don't have a lot of choices. It's either going to be 1 and -7 or -1 and 7. But I wanted to add to get -6. And so that's why I would choose 1 and -7, because 1 plus -7 is -6. 1 times -7 is -7. So it meets those qualifications. And then when I write this as factors, I have to remember that I'm actually solving. And since I'm solving, I'm going to use the zero product property, and I'm going to set each factor equal to 0 to get my solutions. And so I end up subtracting 1 from both sides. And so I end up with p equals -1. And then over here, I would add 7 to both sides, which would give me p equals 7. So my solution is -1 and 7. And the way they want you to do the solution set is just to type in -1, 7. All right, let's move on to number 2. So you'll see that number 2 is quite similar, except for my quadratic, I noticed that it's not already set equal to 0. And so that's always going to be my first step, is I want to make sure to set it equal to 0. All right, so I already have 8u squared minus 7 on the right side. So I personally, I'm going to choose to move the u over. And in order to do that, I just would do the opposite sign. So I would just subtract u really from both sides. And I'm going to rearrange it. And so I would end up with 8u squared minus u minus 7 equals 0. Okay, now at this point, you have some options. I know that I can solve this by factoring, but I could also use the quadratic formula. And since I do the quadratic formula a few times later on in this video, I'm going to go ahead and do factoring, but I will mention that this is the advanced type of factoring simply because this leading coefficient here is not a 1. So I would do the AC method where I'm going to multiply A times C, and I'll be doing factor by grouping. All right, so A is 8 and C is -7. So A times C is 8 times -7, which is equal to -56. And I'm still looking for the number that adds to get the middle term, or the B term, which is -1. All right, so I'm looking for two numbers that add to get -1, that multiply to get -56. It might take me a little while to find those two numbers, but because 8 and 7 only vary by 1, I kind of already know it's 8 and 7. But I want it to be a -1 whenever I add them together. So I want that 8 to be negative. All right, and -8 times 7 is -56. -8 plus 7 is -1. Now, if you remember with factoring by grouping, we're going to use these numbers, but we're going to split this term here. And I'll do this in red. So I'm going to have -8u plus 7u. And then the 8u squared, so I just want to point out that the 8u squared and then -7, it's just going to drop down. I'm not going to change that. All right, so let me rewrite that. So I'm going to have 8u squared, and then the -7 just drops down, and of course it's equal to 0. Okay, so if you remember, once we get to this point, we then do factor by grouping. So I'm going to group these two together and these two together. And then I'm looking at what they have in common. So 8u squared and 8u have an 8u in common. I'll do this in blue. So I'm going to take out an 8u. And then I can think of this as what times 8u would give me 8u squared, or 8u squared divided by 8u, I would have a u remaining. And then for negative 8u divided by 8u, I would just have a negative 1. Okay, then for my other two pieces, for 7u minus 7, I have a 7 in common. And since this is a plus, the plus just drops down here, and I'm able to take out a 7, and I would have u minus 1 remaining. It's always a good sign when your binomial matches, or your factor matches. That's always a good sign, because then I can factor that out. So I have u minus 1 and 8u plus 7 equals 0. And then I'm going to set each of these equals to 0. So I'm going to have u minus 1 equals 0, 8u plus 7 equals 0. I'm going to add 1 to both sides, and I get u equals 1. I'll subtract 7, and then I'll divide by 8, and I get u equals negative 7 over 8. All right, so my solution set would be negative 7 over 8, comma 1. Keep in mind that I can always check my solution by plugging it back into the original and making sure it makes a true statement. All right, let's move on to number 3. So number 3 says, solve the equation by using the square root property, write imaginary solutions in the form a plus bi. Okay, so this one is not bad. It's kind of like warming us up to the square root property. So I can just go ahead and take the square root of both sides, because the h squared, to undo that, the square root would be the opposite operation. But I want to remember to include plus or minus. And so I take the square root of both sides. I've got my plus or minus the square root of 2. And so I have h equals plus or minus the square root of 2. And when you type this into Alex, you will have the option to use the plus or minus key, or you can write it as negative square root of 2, comma square root of 2. Alex would accept either answer. All right, so let me just go ahead and type that in, or sorry, write it in. Okay, let's try number 4. So for number 4, we're solving the equation by using the square root property. Again, and we're writing any imaginary solutions in the form a plus or minus bi. All right, so I have t squared minus 11 equals 0. And this time I'm going to have to do a little more work to isolate the squared part, the t squared part. So I'm going to just simply add 11 to both sides of my equation. And so then I have t squared equals 11. Then I will take the square root of both sides. I won't forget the plus or minus. And I can't reduce 11, so I'm actually just finished, which happened with the square root of 2 as well. So I have t equals plus or minus the square root of 11. Very similar to the last problem, I can write it as 2 answers, or I can use the plus or minus key feature. Okay, so now we're going to move on to one that's a little more difficult. We're going to solve using the square root property again, but this is going to require a little more work, and also we're finally going to have the I solution. All right, so I want to show you what that looks like. So I have negative 3a squared is equal to 12. I always want to isolate the a squared part first. Okay, so in order to do that, I need to get rid of the negative 3. And since it's negative 3 times a squared, it makes sense that I'm going to want to divide both sides by negative 3 first. And so then I have a squared equals negative 4. And then I can go ahead and take the square root of both sides. I don't forget the plus or minus, of course. And so I have a equals plus or minus, and the negative, remember that I is equal to the square root of negative 1. So the square root of negative 4 is really I square root of 4, but the square root of 4 is 2, so it will become 2i. So I end up with plus or minus 2i. And once again, I can write that as plus or minus 2i, or I can separate the two solutions, which would be negative 2i, comma 2i. All right, let's move on to number 6. All right, number 6, we are going to solve by using the quadratic formula, and we're going to express the solution in the exact simplest form. And one thing that I want to point out here is the quadratic formula, I should say. Okay, so if you recall, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And if you're getting to use a reference sheet on your test, you're going to want to put that formula somewhere for sure. Keeping in mind that in order to use this formula, the quadratic needs to be in the format ax squared plus bx plus c equals 0, where of course a and b could not be 0 because then it wouldn't be quadratic. And we're already in this form, so that's cool. I like to first declare what a, b, and c are. So remember, a is just the number in front of x squared, which in this case is a positive 1. B is the number in front of x, which is negative 7. Oops. And C is the constant, or the final remaining number here, which is negative 3. All right, so C is negative 3. Okay, so now I'm going to be plugging this into what I like to call the skeleton of the quadratic formula, where I just kind of get everything ready to go in to its designated spot. And so I'm just going to replace everything that has a variable with parentheses, and then I'm going to start to plug the numbers in. So I'm going to have b, which is negative 7, will go in two places. It goes here and also here. And then a goes in two places. So here and here. And then c only has one spot that it goes into, which is right here. Okay, now that I have that listed, the next step I would tell my students to do is to figure out what this discriminant is. The discriminant is going to help us with our work to finish this problem. It's very important that we find that number correctly. It's the most important number. So you might want to find that number, pause the video if you'd like, and let's make sure we all get the same number, because that's kind of a big deal. All right, if you did it correctly, you should have got the number 61. And if you need me to, I'll go off to the side and I'll do that for you. I'll do it down here. So it'd be negative 7 squared minus 4 times 1 times negative 3. I would tell my students, sure, do it by hand, but definitely check it with a calculator. It's very easy to make a mistake. So I'll do this by hand, but I've already checked it with my calculator. Negative 7 squared is negative 7 times negative 7, which is positive 49. And then I have this minus here, but when I multiply 4 times 1 times negative 3, I get a negative 12. So it becomes 49 minus minus 12, which becomes 49 plus 12, which is how I get 61. Okay, that means I'm going to have a 61 inside of my square root, and then I can kind of clean up the other stuff here. So this negative negative here becomes a positive 7, and then 2 times 1, of course, is just 2. Now at this point, I notice a few things. I notice that 61, I can't break that apart as two numbers, and then there's no perfect square, so I can't actually simplify the square root of 61. And because I can't simplify it, I'm basically done with this problem. And I could rewrite it as 7/2 plus or minus the square root of 61 over 2. Oh, sorry. Which is kind of how I prefer to write it, because sometimes we're able to at least reduce our fractions. But I will let you know that Alex would accept either this answer or this answer. You could even break it apart as two answers if you would like. All right, let's try another one. Okay, we're going to be using the quadratic formula again, but we have to do a little bit more work, and this problem is a little more challenging. So first, I have to get everything on one side of the equal sign, right? So this, I'm going to move over here to the opposite side of the equal sign. And when I do this, I just really need to perform the opposite operation to both sides so that it cancels out. So the negative 8x, I would add 8x to both sides. And so it's going to become a positive 8x. And then the negative 19, I would add 19 to both sides. And then I have it set equal to 0. Now I can start my quadratic formula. So I'm going to let a equal 1. That's the number in front of x squared. B is equal to 8. That's the number in front of x. And c is equal to 19. I'm going to go ahead and plug this into my quadratic formula just like we did on the previous problem. So I'm going to have negative b plus or minus the square root of b squared minus 4ac all over 2a. And you can see I just did the skeleton as I was talking, but I always use parentheses when I'm plugging things in. I'm going to go in the same order that I did last time. I need to figure out what this very special number is. This number matters like a whole lot. So I'll give you a moment to pause the video to find that number. All right, you should get negative 12 when you perform this operation. This becomes 64 minus 76, which gives you negative 12. So I'm going to have negative 8 plus or minus the square root of negative 12 over 2. Okay, now this becomes really crazy because I have a negative inside of my square root, which means I'm going to have an I. Also, I can reduce the square root of 12 because that's 4 times 3. And so there is a perfect square of 4 inside of 12. And so this is actually going to become 2i square root of 3 over 2. Okay, so what happened was the 12 reduces to, or simplify, the 12 factors to 4 times 3. I know the square root of 4 is 2, and then I would have the square root of 3 remaining. Now from here, it is actually essential that you break it apart because we can reduce. I see some very interesting numbers here that I'm going to be able to reduce. You could make a triangle and reduce them all at once, but I'm going to follow the order of breaking it apart because sometimes you're not able to reduce both numbers. And so I want to show you that if you break it apart, you can always just reduce what you can. So I can reduce negative 8 over 2, and that's 2 over 2 here as well. And so what this finally becomes is negative 8 over 4, negative 8 over 2 becomes negative 4. And then 2 over 2 becomes just a 1. And so the 2's basically vanish. And I'm left with negative 4 plus or minus I squared root of 3. And that could also be broken apart if you wanted to, but you can also just use that plus or minus key that Alex gives you, and that would be definitely the quickest way to write that in. All right, let's move into another solving quadratic, and then we're going to move on to solving different types of equations. Okay, so this one is even farther away from that ax squared plus bx plus c. So we're going to want to distribute first, and then do what we need to get it in that ax squared plus bx plus c form, right? So w times w is just w squared, and then w times negative 4 is negative 4w equals negative 5. Okay, now we're closer. We can just move the 5 to the other side of the equal sign by adding it to both sides, and then we can use the quadratic formula. So this becomes w squared minus 4w plus 5 equals 0. And then I've got a is equal to 1, b is equal to negative 4, and c is equal to 5. And then I'm just doing that same operation with my quadratic formula. Okay, so let me plug in my numbers. I've got negative b, so negative 4, plus or minus the square root of b squared minus 4ac, which I've already plugged in for you, all over 2a. Now I want to find that most important number before I move on. So I'm going to find this most important number here, which we call the discriminant. That would become negative 4, because it would be 16 minus 20, which is negative 4. So I'm running out of room, so I'm going to go a little bit to the right here. All right, so I have, and I'm going to clean up this negative over here. It's going to become a positive 4. So anytime your b is a negative, once you plug it into the quadratic formula, it makes sense that it's going to turn positive, that front leading term here, because of the double negative. All right, so 4 plus or minus the square root of negative 4 all over 2. But I know that the square root of negative 4 can be simplified. If it can be simplified, I have to simplify it. Since there's a negative, I know I'm going to have an I. So it's like I squared of 4, but the square root of 4 is 2, so this becomes 2i. So then I have 4 plus or minus 2i over 2. I break apart my fraction. I can write this as 4 over 2 plus or minus 2i over 2. I reduce. 4 over 2 becomes 2, plus or minus, and then this 2 over 2 here becomes just a 1, so those to go away, and I'm just left with I. So my final solution set would be 2 plus or minus I. All right, although quadratics are a lot of fun, we're now going to move on to some rational solving. And that includes with fractions, but you don't have to worry about fractions. They're not that bad. And I would just say that on number 9, since we have basically t plus 4 over 4 equals 3 over 20, I can actually just cross multiply to solve right away. And so that would be 20 times t plus 4 is equal to 3 times 4. And then I just continue to solve. So 3 times 4 is 12. I want to distribute my 20. So 20t plus 80 equals 12. And then I just need to solve this linear equation. So I'm going to subtract 80 from both sides. And when I do that, I end up with negative 68 here. And then the 20t drops down, it's 20 times t, so then I just divide both sides by 20. And I end up with negative 68 over 20, which of course reduces. And so when I reduce this, it reduces to negative 17 over 5. All right. Let's try number 10. So number 10 is going to be a little more challenging. For number 10, the first thing I'll say is that if I end up with 6 as an answer, it would not be a good answer. It'd be extraneous because I always like to look before I start to solve. What would make my denominator equal 0? So no matter what, y cannot equal 6. If I end up with that solution, then I would have the empty set. But I don't end up with that solution. I'm just pointing that out. And I'm going to go ahead and solve this, but I like to do what I call clear the fraction. And so to clear the fraction, I just need to multiply by the denominators, which in this case is 6 and y minus 6. So I'm going to multiply each piece by this, and some things are going to cancel out. And if you do this correctly, you're not going to have a fraction anymore. All right, so I'm going to do this, I'm going to try to do this in blue for you. So I'm going to multiply 6 times y minus 6, 6 times y minus 6 to both sides. And when I multiply the first piece here, then what would cancel out would be the y minus 6 and the y minus 6. And so I would be left with 6 times y. So that this first piece becomes a 6y. When I multiply the second piece by 6 times y minus 6, the 6's cancel out. Okay, the 6's would cancel out. And all I would have left is the 1 times the y minus 6. So plus 1 times y minus 6. Now I know that when I distribute that 1, it just remains a y minus 6. But in case it wasn't a 1, we still want to write it because I'm trying to show my work. Okay, now for my last piece, I'm actually going to cross out for you. So when I multiply 6 times y minus 6 times my last piece, the y minus 6 cancels out, and I'm just left with 2 times 6, which is 12. Okay, now I'm going to clean this up. This piece right here, it's just a positive 1. So it's just going to be 6y plus y minus 6 equals 12. And then I'm going to combine my like terms. So 6y plus 1y would give me 7y. So 7y minus 6 equals 12. I would add 6 to both sides, which gives me 18. And then I would divide both sides by 7. So y is equal to 18 over 7. And that would be my solution set. All right, let's keep going. So number 11 is a application problem for rational functions. All right, so it says that suppose that 40 deer are introduced and protected in a wilderness area. The population of the herd can be approximated by this equation, where x is the time in years since introducing the deer. Determine the time required for the deer population to reach 220. All right, so I've got P equals, which P stands for population. And I'm going to rewrite this equation. And what I'm trying to do is I'm trying to figure out when is the population going to reach 220, right? And so that's actually what I would be plugging in. I would plug 220 in for P, and then I'll just be able to solve this. And I will use cross multiplication because we've done that before. And I can do that. I can just put the 220 over 1 and I'll be able to cross multiply. So I'm going to scoot over a little bit so I have a little more space. So when I cross multiply, I'm just going to do 220 times all of that and then 1 times all of that. And so I get 220 times 1 plus 0.05x is equal to 1 times 40 plus 20x. And I realize that it's just a positive 1 on the right side. And so this is just going to become 40 plus 20x, right? But over here, I actually need to figure out what those numbers are, right? So 220 times 1, of course, is just 220 plus 220 times 0.05. So 220 times 0.05 is equal to 11x. Okay, now I'm ready to solve. And remember, when you're solving this linear equation with variables on both sides, you want to get all of your x's on one side and all of your numbers on the other. And you can do that one of 4 ways to start. So I apologize if I don't do it your special way, but I'm going to go ahead and move the 20x to the left side. And that's going to give me negative 9x. And then I'm going to drop this down. And now I'm going to get my numbers on one side of the equal sign. So then I'm going to subtract 220 from both sides. And that will give me negative 180. And then I divide both sides by negative 9. And I end up with 20. Okay, so I will say that while that was fine, there is a different way I could have started that problem. So let me backtrack. So bear with me. So when I go back to this equation, as I said, there's 4 different ways to start the problem. I always like to get my variable on the left side of the equal sign because I think it helps students. But I will tell you that another thing that some of you probably did, and that's just fine, is maybe you subtracted 11x from both sides first. And that would have been okay too. I would have 40 plus 9x equals 220. I just want to show you we get the same result. Then I can subtract 40 from both sides, and I get 180 equals 9x. Then I can divide both sides by 9, and then I end up with 20 as well. So either way, I get 20, but there are 4 different ways to start that problem. Now, I'm not going to do all 4, but I at least wanted to do 2 of them for you. All right, so it's going to take 20 years for the deer to reach the population of 220. All right, so let's keep going. We're now going to move into a different type of solving, which involves radicals. So on number 12, we're going to solve the cube root of 5x minus 2 minus 1 equals 1. And the first thing we're going to want to do when we solve a radical equation, whether it's the square root or the third root or the fourth root, is we want to make sure it's isolated. So the first thing I want to do is I want to go ahead and move 1 to both sides of the equal sign. And that's going to give me the cube root of 5x minus 2 is equal to 2. Then I can cube both sides. Now that I have the cube root isolated, I can just go ahead and cube both sides. When I cube the left side, the whole point is to get this inner part here, which is 5x minus 2, to be released. So the cube root goes away because I cubed it, and then 2 cubed is 8. And then I'm going to continue to solve this linear equation. Divide both sides by 5, and I end up with x equals 2. All right, let's try number 13. So for number 13, we have the fourth root of 2x plus 6 is equal to the fourth root of 7x minus 9. They are both the fourth root, so we can just right away, and they're both isolated, we can right away raise them to the 4th power, and then something really cool happens. So I end up with 2x plus 6 equals 7x minus 9, which is like really exciting that we can just end up setting them equal to each other. This is very similar to the problem we just had as far as the next part of the solving goes. I need to get my x's on one side of the equal sign, and I need to get my numbers gathered onto the other side of the equal sign. So I'm going to do the same thing. I'm going to subtract 7x from both sides, and that will give me negative 5x plus 6 equals negative 9. And then I would subtract 6 from both sides to get negative 15 is equal to negative 5x. Divide both sides by negative 5. And I end up with x equals positive 3. This is an even power that we raised it to. So we're going to want to definitely check our answer and make sure it's not extraneous. So I can kind of already see that it's not going to be, but I'm going to go ahead and plug it in just to show you. So this would be 2 times 3 plus 6, which would be 12. So on the left side, we'll have the 4th root of 12. And then 7 times 3 minus 9 is 21 minus 9, which is 12. So you can see that they are equal. And so our solution is viable and good. And so anytime we raise it to an even power, we're always going to want to check our solutions. All right, let's move into a different type of solving, which is the higher order polynomials, which we solve by factoring. So I have x to the 4th plus 2x squared minus 8 equals 0. I will factor this, and I'm just looking for two numbers that add to get the middle term, that multiply to get the last term. However, since this is x to the 4th power, to account for that, I'm going to have x squared and x squared. And if you want to make the x to help you, you can. So I'm going to think about what times what equals negative 8 that would add to give me a positive 2. So I feel like it's going to be 4 and 2, but I would need the 4 to be positive and the 2 to be negative so that whenever I add it together, I get a positive 2. So I'm going to have positive 4 and negative 2. And of course, that is set equal to 0. So then I'm going to set each piece equal to 0. And with our quadratics, we typically, would have two solutions. Sometimes we could have one if it was the same answer twice. But with our 4th power, it's possible we'll have 4 answers. And so I'm going to make sure to find all 4. So I subtract 4 from both sides, and I get x squared equals negative 4. I take the square root of both sides. I don't forget the plus or minus. And I have x equals plus or minus 2i, because remember, the square root of negative 4 is 2i. I can take out the I, and then the square root of 4 is 2. And then over here, I would add 2, and then take the square root of both sides. Don't forget the plus or minus, and I end up with plus or minus the square root of 2. So I have 4 answers. I have plus or minus 2i, and I have plus or minus the square root of 2. I could also write this as negative 2i, positive 2i, negative square root of 2, positive square root of 2. And it should accept either way that you type it in. So we are almost done. We have just a few more. Okay, so I'm going to solve this equation. I'm going to use factoring, and I can see that it's to the 3rd power. And I notice right away that these 3 numbers are divisible by 3. And so it's likely that you'll have one where you can take out your leading coefficient. So I'm going to take out a 3, but they also have an x in common. So I'm going to be taking out a 3x from each piece. So 3x cubed, and if I take out a 3x, I'm going to have x squared remaining. 30x squared divided by 3x is positive 10x. And then 72x divided by 3 is 24. All right, and then I'm going to be able to continue to factor. So I'm looking for two numbers that add to get 10, multiply to get 24. And I can list the numbers of 24 if I need to, like what times what equals 24. And hopefully, eventually I see that it's going to be 4 and 6, right? So positive 4 and positive 6 will give me a positive 10 when I add it together, and when I multiply, it also gives me a 24. All right, now I've got my 3 factors. I'm going to set each piece equal to 0. I'm going to set the 3x equal to 0. I'm going to set the x plus 6 equal to 0, and I'm going to set the x plus 4 equal to 0. And when I set 3x equal to 0, it's really 3 times x, so I just divide both sides by 3, and then 0 divided by 3 is 0. So 0 is one of my solutions. Then I subtract 6 from both sides, I get negative 6. Subtract 4 from both sides, I get negative 4. And so I have negative 6, and negative 4, and 0 as my solutions. All right, last but not least, we have a wonderful factor by grouping. Now, I know this is factor by grouping because there are 4 pieces or 4 terms. So I want to group the first 2 together and group the last 2 together. So for the first 2, they have a y squared in common. So let me just rewrite this so I have a little more space. I'm just going to rewrite the whole problem. So 2y cubed minus y squared minus 18y plus 9 equals 0. Okay, so I'm going to group these 2 together and these 2 together. Now, 2y squared and 2y cubed and y squared, they have a y squared in common. And I would have a 2y minus 1 remaining, because whenever I take out a y squared from itself, I would just have a 1. Since this is a negative has to drop. 18 and 9 have a 9 in common. I'll do this in red. And then 18 divided by 9 is 2. And of course, there's a y left over. 9 divided by negative 9 is negative 1. It's always a good sign, though, when those are equivalent. If you do it correctly, you should have similar, or the same factor. So 2y minus 1 and 2 minus y minus 1, I can now factor out. And then I also have this y squared minus 9. Now, this is the difference of squares, but I'm going to go ahead and just set both pieces equal to 0 because I want to follow suit with what I've been doing the whole time. So I'm going to go ahead and set both pieces equal to 0. I'm going to add 1 to both sides and then divide by 2. So I get y equals 1/2. And then over here, I add 9 to both sides. And I have a y squared, though. So when I take the square root, I don't want to forget the plus or minus. The square root of 9 is 3. So I have 3 solutions. I have negative 3, positive 3, and positive 1/2. All right, I hope this video helps you. I hope you do well in your test. Bye.